Good morning, dear students. We are moving ahead with Module 5 and we are going to introduce a new topic called genetic algorithms. The next two lectures, this one and the next one will be on genetic algorithms. Before moving to genetic algorithms, let me first ask you, what is optimization? You should be very thorough with this term, optimization. So, optimization is actually the process of making something better. Okay? So, for any system, you know that you have a set of inputs, you have some process and you get a set of outputs. So optimization actually refers to finding the best combination of inputs which yield the best result. So what is this best? It varies from problem to problem. For example, suppose that this process is a manufacturing process. Okay, this process is a manufacturing process for manufacturing some material. So the inputs are, you need to set the temperature to some value, you need to inject or give plastic pellets. It's some injection molding. For injection molding, you need plastic pellets, that is another input. You need some other polymer, that is another input. You need some solvent, it is another input. And you need to set the speed of the machinery to which speed of this process. These all are some examples of some input parameters. I just wanted to make you more understand, that's why I am telling this example. So, what should be the optimal setting of all these inputs? Means how many plastic pellets you should give, what should be the temperature setting, and what should be the amount of polymer that you need to give, what should be the optimal speed of this process in order to get the best product which is most stable, or there will be some criteria for measuring how durable the product is. So what should be the combination of inputs in order to get the best product, or what should in another way the output can be defined in another way. What should be the combination of inputs in order to get the product with least cost? It can be that way also. Sometimes durability may not be the issue. Sometimes cost may be the issue. So, in order to yield the best depends upon problem to problem. Sometimes it can be the most durable. The best one means the most durable. Sometimes the best means the least cost, and so on. Okay? So actually optimization means selecting the best inputs or combination of inputs that can be applied to a process in order to yield the best result. So actually the set of all possible solutions which the input can take make up the search space. So in this search space, there will be a point or set of points which will give you the best solution. So the aim of optimization is to find that point. Like I told you earlier, just a second. Like I told you earlier, okay. Some delay, just wait. Like I told you earlier, for the earlier process, what are the inputs that you can give? What are the inputs you can give? I'll take another text box. I told you the inputs you can give are, say, temperature. Just imagine that your temperature can vary from some 20 to 50. That is a temperature range that you need to choose. Then you need to give plastic pellets. say you can give some 10 pellets to 50 pellets. Then you need to give some polymer. Maybe it is also in the form of pellet. You can give from it is required only in a little amount, so from 5 to 15. Now another input is speed of the machine. Speed of the machine can be from, say, it can move very slow from about 10 rpm to about fast 100 rpm. So let us say these are the combination of inputs for a manufacturing process, and the output is, say, most tough or durable product. So in this example, as I told you, there are many combinations of input possible. For example, you take temperature of 20, plastic 10, polymer 5, speed 10. That is one combination of input. It will give you a product and you can measure the toughness of that product. Now, another input combination is temperature 25, plastic 15, polymer 10, speed 50. So likewise, since all the inputs have this range, there are numerous combination of inputs possible. So the set of all such solutions, so each of the combination of inputs can be the solution for the problem. That is, out of all the combination of inputs, only one or two or a few will yield the best solution. All the combinations will not be optimal for producing the most toughest product. So the set of all possible combinations is called actually the search space, and in that search space there will be one combination or one set of point which will give you the best product. So the aim of optimization is to search and find that point or set of points which will yield you the best solution. I hope what is optimization is almost clear to you now. Now, why did I tell you about optimization? Because we are going to handle with genetic algorithms, and genetic algorithms is actually a search-based optimization technique. That is, of the all possible solutions, genetic algorithm will help you to find the best one, best output or best product or something like that. And genetic algorithms works on the basis of genetics and natural selection. And it is usually used to find the optimal. Optimal means the best, near optimal. Sometimes genetic algorithms doesn't give you the best one, but almost best, near to best solution will be provided to some problems which would otherwise take a lifetime to solve. What is the meaning of this? The meaning of this is that sometimes in the previous, just an example which I told you, I had just 4 inputs or so. So there were maybe other processes or other, say, some designs which require about numerous inputs, hundreds of inputs. So choosing the best combination of input in that case becomes a very tedious process. It may take days to solve that. It means that you need to find each combination. Say you have 100 input variables. You need to take the first combination, check what is the best product. Take the next combination, check how much durable the product is. So you have to check each and every possible solution, and then out of all the outputs you need to select the best one. So if the input space or the number of input variables or the input space becomes large, the combination of inputs also increases exponentially. So it may take long hours or days to solve that. So always finding the best one is not feasible. So you have to go for some techniques which will give you fast solution, and that solution should be almost the best one. It doesn't matter if it is not the very best one, but if it is almost acceptable solution, we are able to get in limited time. In some cases that is more important. So in that circumstance, genetic algorithms is very useful as an optimization technique. And GA was developed by John Holland and his students at University of Michigan. Now, what are genetic algorithms? Actually, what we have in genetic algorithm is we have a population or group of possible solutions to a given problem. And these possible solutions then undergo recombination and mutation, produce new children, and this process is repeated over various generations. And each of the individual or each of the solution will be assigned with a objective function or a fitness value. And the fitter individuals, the most fit individuals are selected to produce the next generation. So this is actually based on the Darwinian theory of fittest. So what is the meaning of this is that in GA what we do is, suppose we have some 100 input variables. So maybe some 100 factorial ways. The search space can be some 100 factorial. So you can't check the feasibility of each of the combinations of inputs. So what genetic algorithm does is, it starts from an initial group of solutions. Means out of that 100 factorial, it may be choosing some 100 or 200. It randomly picks some 100 or 200 solutions and finds the durability of the product or output of all the 100 or 200 solutions. Then it goes through a series of processes like recombination, mutation, and evolving of the individuals over generations. So what happens is, from that 100 or 200 group of solutions, you do some changes to the solutions, mutation, crossover. You arrive at newer and newer generations, and at the end of say some 50 or 100 generations, you will achieve at the best solution. So this can be done in limited time because you're not checking all the possible solutions. You're just picking some group of solutions and doing some processes on it, some mutation on it to arrive at the best result. This is what is done with genetic algorithms. So now what is the motivation for GA? So like I told you earlier, there are a set of problems which you call it NP hard. It means that it cannot be solved in polynomial time. It may take them years to solve such problems. There are some problems like that in computer science. And GA was found to be an effective tool to provide near optimal. I told you it cannot be always the best one, but almost optimal, almost good solutions in short amount of time. That is more critical. So I've given one example here to make you understand that you all will be using your GPS navigation system to compute the optimal path. You give a source and you give a destination. When you drive the car, you will try to find the best route from one source to one destination. So usually you don't accept delay, right? You want the best route in the shortest amount of time. So actually the best or the optimal route that you're getting will not be the perfect one. It will be almost an acceptable best route, but you are able to get that in short amount of time. So in such cases, you need optimization techniques like GA. It doesn't mean that always this process is using GA. There are many algorithms like this that are like shortcuts to find the best solution. You call it heuristics. Okay? Now, you need to understand some of the basic terminologies in genetic algorithm. First one is population. I told you that you will have numerous combination of input to a process, but GA will select a subset or a group of that, a group from the possible solutions. Say out of some 10,000, you will be choosing some 500 as the starting to the algorithm. It's the starting process, okay? And next term is chromosome. These are all related to biology. So, I told you each possible combination of input or each possible solution to find the best product is represented by a chromosome. So, out of, I told you, you will be selecting a population of solutions and each solution is represented. Means its trait or characteristic is represented by chromosome. So gene is just one element in the chromosome and allele is the value that the chromosome takes. So look here. Here each of this row represents one individual in one population. So this is one population or group of individuals. Each row here actually means one individual and each individual has some trait which is represented by its chromosome, and in that chromosome each of the elements is called gene and the value it takes, here it is 0, is called allele. Now you have something called fitness function. I told you each possible solution or each possible individual should be evaluated based on fitness function. For example, in the example problem I told you each of the combination of inputs will be chosen and you will find if that input combination is taken, what is the durability. So that in that case it can be durability, the fitness function. So I told you sometimes the cost, it is a cost that matters. In that case the fitness function can be your cost. So it can be anything, it is problem dependent. And now what are genetic operators? Genetic operators actually alter the genetic composition of the offspring. It includes crossover, mutation, etc. So what I wanted to tell you is that you start from an initial population or group of solutions to a problem. Then each of that problem will be associated with a trait depending on the problem you are solving. So GA tries to change the genetic composition or the chromosome pattern and then change the patterns and then arrive at the pattern which will give you the best result. So this is the basic structure of GA. Look here. We begin with an initial population. I told you we will evaluate the fitness of each of the solution or individual in that population. Then you will choose the best, say for the next generation you need, you have an initial population of 50 individuals. For the next generation also you need 50 individuals. So what you do is you choose some 100 individuals and take the first two. So the 100 individuals, it's not like that. You take the initial population of 50 individuals. Then what you do is you evaluate the fitness. Then you randomly choose 2. That is called selection. Or you randomly choose 2 means based on the best fitness value. Then you do the crossover. Crossover means it's actually breeding. Like any animals or human beings breed, you do the breeding of the chosen individuals. Then perhaps sometimes you do mutation. So this process will be repeated. So here I have first chosen only 2 individuals. So you get 2 children. 2 offsprings will be actually produced through this process. Now you again take 2. you will get 2 offsprings. So this process is repeated until you get the next 50 individuals for the next generation. And then you evaluate the fitness of that 50 offsprings. You again do this process. So this process will be continued. So each offspring generation will be produced like this. So this process will be continued until some termination criteria is reached. The termination criteria is like, maybe you decide the number of generations that the individuals need to evolve. For example, I am telling, let the GA run for 50 generations or 100 generations. So this process takes place 50 times. Sometimes the termination criteria can be continue this process until the cost is so and so, or durability so and so. Until you achieve the individuals with that cost or that durability, you have to continue the process. So termination criteria can be anything. So this is actually the structure of a genetic algorithm. Now we'll also look at how we are going to encode the chromosome. I told you that each combination of input or each solution to a problem is represented by a chromosome. So what is the best combination of inputs in order to get the best product? So each combination of input is a solution to find the best product, right? So each combination of input or your solution or your individual, you call it individual also, is represented by a chromosome. So how are you going to construct the chromosome, or how are you going to encode the chromosome? Sometimes it can be binary encoding. It means that if you have a chromosome with so and so many elements, each of the element will be represented by either a 0 or it can be represented by either a 1. So certain types of problems require only such kind of representation. For example, you can go and check in the internet what is an knapsack problem. Sometimes for understanding it better, I can say you, sometimes thief or robbers, they bring big sack, right? And what they try to do, suppose that in your home you have n elements. See, some 10 items which the robber is interested in. So which all items the robber will pick and put in the sack, and which all he doesn't choose. So that can be represented by actually this binary encoding. Say the first element here is television. Will he put it or not put it? Say jewelry. The third one is jewelry. Will he put it or not put it? Maybe he will take, right? Because the weight is less. So in the knapsack the weight is less but the cost is high. So the robber always tries to minimize the weight of the knapsack and maximize the value of the items in the knapsack. So each of the n items, whether he has to put in the knapsack or doesn't put, can be represented by zeros and 1, something like that. So for I just told you an example. There are many engineering problems and other problems that can be done using binary encoding. Now the next is real valued representation. So here instead of zeros and ones you have decimal numbers, real values. Next you can go for integer representation. It can be represented by integers. Now you also have permutation representation. Like these are also integers, but the thing is this is one individual. Another individual can be the same with order different. Say the first element is 5, second is 9, third is 8 and so on. These numbers will be used over again and again in different order. So this kind of permutation combination can be used to solve something like a traveling salesman problem. It means a salesman has to visit 30 number of cities and come back to the starting city for some sales purpose. So the thing is, the total, he has to travel and go through the cities in such a way that the total distance has to be minimized. That is your optimization problem. So, genetic algorithm always starts from a set of solutions, right? So, this is one solution. Say this one is your first city, 2 is your second city, 3 is your second city. So, this chromosome says that the person first travels to city 1, then travels to city 5, then travels to city 9, and so on. So this is one possible solution. Similarly, another order gives you another way of going through the cities. So each of these solutions will be evaluated. For example, this will be evaluated based on how much total distance it is creating. The second one will be taken, it again calculates the distance. In this way, for all the say chosen 100 initial population, you will calculate the distance, and the best one will be taken to produce the offspring, something like that. So I think as a starting, this much is enough for today's class. Please go through it 2 or 3 times to get the concept of what is optimization and what is genetic algorithm all about. Thank you so much. Please feel free to ask me if you have any queries. Thank you.